Hello guys, welcome back to my channel. I'm Shams Fatima from Sri Venkateshwara College of Engineering, Bangalore. So today my topic is Intelligent Storage System from the subject Storage Area Network. So let's have a look at the Intelligent Storage System. So what is an Intelligent Storage System? Intelligent Storage System are RAID arrays that are highly optimized for input-output processing, have large amount of cache for proving input-output performance, have operating environment that provide intelligence for managing the cache, array resource allocation, connectivity for heterogeneous host, advanced array-based local and remote replication options. Now, let's have a look at the benefits of intelligent storage system. ISS provides several benefits over the collection of disk in an array, JBOD, or even a RAID array. Increased capacity, improved performance, easier data management, improved data availability and protection, enhanced business continuity support, improved security and access control. So here are the components of an intelligent system. So first, we will have a host connected through FS-SAN, that is FS Storage Area Networking connectivity, which is connected to the front end, followed by the cache, front, back end, and the physical devices. The front end, cache, back end, and the physical devices together are known as the intelligent storage system. So here we have a front end command queuing. So first we will have the input request. A request has to be sent to the front end controller followed by input processing order, which will give rise to a cylinder which consists of A, B, C and D. This is without the optimization, FIFO, first in first out. In the next part is with command queuing. Here we have to have a input output request followed by front end controller, which is followed by the input output processing order, which gives rise to a cylinder A, C, B and D. This is the front end command queuing. So here is the write operation with the cache. So first we will have a host followed by the cache and the physical disk. The host has to send the write request to the cache, followed by the cache will take the command from the host, will give rise to the physical disk. This is write through cache. This is write back cache is nothing but the physical devices will acknowledge and send it to the cache, and then the write request is again sent back to the host. So here is the difference between the write through cache and write back cache in the write operation of cache. So let's have a look at the read operations of the cache, hit and misses. So read operation is also known as the hits and the misses. So here let's have a look at the number of hits the cache will have and the number of misses the cache will have. So data found in the cache is called as the hit. If there is no data found in the cache, that terminology is called as the miss. So here the host will send the data to the cache followed by the physical disk. So here host will send the request to the cache. The cache will understand the request sent from the host and then it sends back to the physical disk. This terminology is termed as the hit. So now let's have a look at the no data found, that is called as miss. The host will send the request to the cache, and then if the data is found, then the terminology is called as hit. If the cache is not able to fetch any data from the host, it sends back to the physical disk saying that it's a miss operation. So this is a difference between hit and the miss. So now let's have a look at the cache management algorithm. So there are basically two algorithms involved in the cache management, that is LRU and MRU. So now the cache management will have the least recently used, and that is termed as the LRU, and the most recently used algorithm, that is called as the MRU. So the least recently used algorithm is the discard least recently used data. In the LRU, there is a discardation of the least recently used data, but whereas in MRU, there is a discard of most recently used data. Assume that the recent data may not be required for a while. So the cache implementation. Dedicated cache, separate memory sets reserved for read and write operation. And the global cache is the both read and write operation uses available memory, which is more efficient. So here are the two types of cache implementation, dedicated cache and the global cache. And hence, global cache is more efficient because of its read and write capability, and it has more memory for the storage of the data. Now let's have a look at the cache management, that is watermarking. Manage peak input-output request, bursts through, flushing, destagging, idle flushing, high watermarking, flushing, and force flushing. For maximum performance, we provide the headroom in the write cache for the input-output burst. The first diagram tells the idle flushing, and the second one is the high watermark flushing, and the third one is forced flushing. Idle flushing does not have a proper force to pull up the water level, but high water level flushing is being pushed through a lot of force, whereas the forced flushing is being flushed without any kind of a force. So the maximum 100% is deserved by forced flushing. So next let's have a look at the cache data protection. Protecting the cache data against the failure. Power failure. So the cache mirroring and the cache vaulting. Cache mirroring. Each write to the cache is held in two different memories location on two independent memory cards. Cache coherency. Only writes are mirrored. Cache vaulting. Cache is exposed to risk of uncommitted data loss due to the power failure. In the event of the power failure, uncommitted data is dumped to the dedicated sets of a drive called vault drive. So this is an intelligent system for the backend. It has the host followed by a connectivity with FS-SAN, that is storage area networking, followed by front-end cache backend. Everything is connected to the physical end. It has controllers and the partitioners. So the front end, cache, backend, and the physical disk together consist of the intelligent storage system. So the same is followed by intelligent storage system for the physical disk. Now let's have a look what is the host sees, RAID, sets, and LUNs. So the LUNs is logical unit numbers. And RAID, as we know, it stands for redundant array of independent disk. So there are two hosts now, the host 1 and the host 2. Both of them are connected through FS-SAN followed by the front end, cache, backend, the physical disk. And the physical disk will have LUN1 and LUN2, that is logical unit number. Now let's have a look at the LUN masking. It is the process that provides data access control by defining which LUNs a host can access. LUN masking is access control mechanism, process of masking LUNs from unauthorized access. implemented on storage area and at front-end controller. Intelligent storage array, high-end storage system, and the mid-end range storage system. Now let's have a look at the ISS implementation high-end storage system. So here is a diagram for active configuration. Active configuration consists of host and the storage array. The host will send the data to the active storage array and it will give back the feedback to the host. Also referred as active arrays. Input outputs are served through all the available paths. Following our high-end array capabilities, large storage capabilities, huge cache to serve most input-output of the host, fault tolerance architecture, multiple front-end ports and support to the interface protocol, high scalability, ability to handle large amounts of current input outputs, designed for large enterprises. Now let's have a look at the mid-range storage systems. It has active-passive configuration. Here, the commands used are active and passive, but whereas in the high storage system, both the commands were active-active, also referred to as active-passive arrays. Host can perform input-outputs to LUNs only through active paths. Other path remains passive till active fails. Mid-range array have two controllers, each with a cache, RAID that is redundant array of independent disk controllers and disk drive interfaces, designed for small and medium enterprises, less scalable as compared to high-end array. So now let's have a look at the summary of what have we learned today. So the key points covered in this chapter are intelligent storage system features, components of the intelligent storage system, cache management algorithm, intelligent storage system implementation that consists of high-end storage array and the mid-range storage array. I hope you got some information from this video. Please do like, share and subscribe. Thanks for watching my video. Bye guys.